Okay, so we started volumes with known cross-section. So we start with a base shape that's a 2D area, and then out of that area we build off or build up either squares or triangles, or semicircles, or any variety of things. So we have to know those area formulas. Most of them you already know. Again, the new one that you could figure out, but you probably don't want to figure it out, you just want to memorize it, is an equilateral triangle, root 3 over 4, s squared. That's the main one to memorize. The rest you can figure out. You can memorize if you want to, but you can also just figure it out. We did a couple of examples. We got to number 3 and we sort of raced through it. So let's back up and finish number 3 for real. So we said R is this region bounded by e to the negative 0.5x and x squared. This is almost certainly going to be a calculator problem. So I'm just going to go ahead and label them now. There's y1, and this one will be y2. That way, if I get lazy and just write y1 and y2 later, the grader will know what I'm talking about. So e to the negative 0.5x and x squared. And I really don't have any idea what window to look at. So there's the standard window. And that's not bad. I can still see the area down there, but it might be better to zoom in a little bit. I wonder if I can just zoom in, and sometimes it zooms too far when you zoom in. But that one was perfect. That's exactly what I want to see. Okay, so R is that region, that area. And that's what we want to find first, is just the area. So top minus bottom from A to B, but I got to figure out what A and B are, so I need those intersections. So second calc, intersection, it walks you through the steps, but if you've only got 2 graphs, it's pretty easy. First curve, yes. Second curve, yes. And then guess. I'll have to do this twice to get both intersections, but there's my first intersection. Negative 1.4296, and on and on and on. I don't want to write all that down. I certainly don't want to have to write all that down multiple times. So I'm going to store that as A. So there's A. My calculator now knows what A is, so I can use A in my equation in a minute. And now I need to go do the same thing for B. Second calc, intersection, first curve, second curve, guess is over here. Thank you, sir. 0.8155. But again, I'm going to write down that once, not again, because I'm going to let my calculator remember what that is. So you go back to the main screen, and again, if you hit store, the calculator automatically knows that what you want to store was that x value. Store that one as B, and it puts that value back on the screen again so that you can be like, oh yeah, that's right, that's what I want. So now I know A and B. Now for area is just top minus bottom from A to B. And in fact, now that I have y1 and y2 in there, use that. Math 9 from A to B of y1 minus y2. And that looks really simple on the home screen because the calculator knows what A is, it knows what B is, it knows what y1 is, it knows what y2 is, and so it makes it simple to write that in there. And there's my answer, 1.603. That question was like part 1 of this unit, or day 1 of this unit, the area day. Part 2, if R, so that area R is the base of a solid, cross sections perpendicular to the x-axis. You like that? That means dx. Isosceles right triangles with a leg in region R. So we're building triangles up out of the base there. And that's S, and this is S, and this is S. Find the volume of that solid. Okay, volumes of cross section. So this is sort of always the same first formula. From A to B, I'll add up the areas times the thickness. This one's nice because I already have A and B, so I can just leave that as is. How about the area of a isosceles right triangle? Yeah, 1/2. I'm going to do 1/2 s squared dx. How do I figure out what s is? What is that length? Picking on people, I guess. Ambria, how about s? How do I figure out what it is? Or do you know? Not sure. Okay. You're okay with this? That's S right there? And so anytime, I keep forgetting to grab a ruler, I want to measure the length of that, I can do the top minus the bottom. Same way I did here. So that length is the top y value minus the bottom y value. So that's y1 minus y2. A to B, y1 minus y2 squared dx. So anytime you want to find a length, it's either top minus bottom or right minus left if it's a left-right length. Math 9. Again, the 1/2 can go inside or outside. That doesn't matter. A to B. And I could type in y1 and y2, but I don't need to do that. I've already got, the calculator knows what they are. Careful with the parentheses. y1 minus y2 squared dx. 0.687. Is that volume? Before moving on, we talked before when we did the area problem, if you get the top and bottom backwards, what would that do to your area answer? If you switch top and bottom, it'd make it negative. And you would know that, wait a minute, that's not right, because I can't have a negative area. So that would be a good hint that something's not going on correctly there. What happens on this volume problem if you get the top and the bottom backwards? If you get y1 and y2 reversed, how does that affect your answer? Why are you guys shaking your head? You're right. It's squared. So there's a little bit of forgiveness on some of these squared problems, because if you get it backwards, it won't matter. So that's kind of nice on these. You can get this backwards, square it won't matter. And since you still get the same answer, no one's going to be taking off for that, even if you get it backwards, because it's the same thing. All right, number 4. Find the volume of a solid whose base is bounded by the circle. X squared plus y squared equals 25. with square cross sections perpendicular to the x-axis. So we have like squares coming up out of the page here. I don't want to draw too many of them, or then it looks kind of crazy. So I want to add up all the areas of squares. dx. Justin, what are my limits going to be? Am I looking for x limits or y limits? I guess that's the first question.
X limits.
X limits. And so from what to what for this problem?
I don't know. It'd be 2 to 2.
I want to get all the way from here to here.
So negative 5 to 5.
Negative 5 to 5. There is a slightly different way to work this problem. And if you're using the calculator, it doesn't matter, but if you're doing it by hand, it might be helpful. You could change your limits to 0 to 5 and multiply by 2. So sometimes, especially if you don't have a calculator, it might be easier to evaluate 0 than negative 5. So you can be on the lookout for that, kind of make your life easier. You could go 0 to 5 and then multiply by 2. Be careful though, that only works if the thing is symmetrical, so be on the lookout. Okay, I know what the area of a square is. That's side squared, where there's my S. But the reason this problem is on here, S is, top minus bottom, but that's like one equation. Like the top and the bottom are the same equation. So something weird is going on here. If I'm doing a dx problem, I need an equation that only has x in it. So I need to solve this for y so that I get an equation with x. Y squared, 25 minus x squared. What happens when I take the square root? Plus or minus? Square root, 25 minus x squared. And so how do you make sense of this plus or minus and this graph? The minus is the bottom piece, and the plus is the top piece. So the top piece is square root 25 minus x squared. Bottom piece is negative square root 25 minus x squared. Okay, so that side length is top minus bottom. Negative 5 to 5. Root 25 minus x squared minus the bottom one, which is negative square root 25 minus x squared squared dx. So all that is the side length. Debating now, like how much math do I want to do on my own and how much do I want to put in the calculator. I can put all of that in the calculator right now. But what's root 25 minus negative root 25 minus x squared? That's 2 of them. So it's up to you. You want to put that in the calculator? That's a lot of typing. You want to simplify it a little bit and put that in the calculator? If you make it that far, you can square 2 and square 25 minus x squared. It's up to you. I'm hesitant to do too much on my own, so I'll let the calculator do the work. Negative 5 to 5. I'm not going to put all that in there. I'm going to do the little bit of simplifying on my own. 2 square root 25 minus x squared square all of that dx. I get 666.667. Looks like it would be a fraction of some sort, but number 5. This is how free response questions usually look in the AP test world and on our test next week. So the test next week will have one free response question, and it won't be exactly like this, but the format of where you find the area and then you find a volume and some other volume. Like, that's a very common free response for this section of questions, and that'll be the same next week. In fact, I think it's even a 3-part thing, where it's area, volume, and then one other curveball question. Okay, let S be the region, first quadrant, bounded by the graphs of y equals x squared. It's nice when you can easily tell which one is which. And y equals 4. Find the area of S. So we're looking for that area. Okay, too much me talking. Part B, region S, the base of that solid, equilateral triangles as the cross sections coming up out of the page. So that means, hard to draw, I guess, but equilateral triangles. So we want a volume. So I'm going to add up all of the area times the thickness. And each of those triangles has a thickness of dx. So with the thickness of dx, what does that mean about my limits, Jameson? Still 0 to 2. But now I need the area of a equilateral triangle. That's the one I said you want to memorize. Maybe you don't have it memorized just yet. Maybe Abby needs to look it up. Root 3 over 4 s squared. Abby, do you have that memorized yet, or did you look it up? You got it? Okay. That's the only one, so it shouldn't be too long before you've got that one down. Root 3 over 4 s squared. But I can't put that in the calculator because I don't know what s is yet. So, Jace, what's the, I mean, there's s, like the side length I'm talking about, but what is s? How long is s? And you can give me like a generic answer to that, or you can give me specific to this problem answer to that. Like, how am I going to figure out how long s is? So even that's right now down to just put it in the calculator. Like, part C. Region S is the base of a solid, equilateral triangle cross sections, perpendicular to the y-axis. So that means my triangles are kind of going this way. So what's the big change that's going to be to my integral? Those are dy slices. Those triangles are all dy thick. Okay, so that's going to change some things here. It's going to change a lot of things. That's people who aren't playing baseball or softball today. Luke, what about my limits? What are they going to be? Are they going to be x limits or y limits? Let me walk you through it.
Y limits.
Other than Austin whispering that, how did you know?
Well, you drew like the dy arrow.
Okay. Once you know that it's dy, that means your limits have to be y limits. Okay? So your brain has to shift or turn your head or turn your paper or something's got to turn 90 degrees here. So Luke, from what to what then? What specifically in this problem will my y limits be?
Is it 4 to would it be 0 or negative 1? 0?
0 to 4.
Yeah.
Here's the area. 0 to 4. Oh, maybe I need to measure another length here. It's still 4, but okay, this is silly maybe, but maybe it'll help you remember. So obviously it's still 4. Where does 4 come from on that ruler? Where am I getting 4 from? Right minus left. 9 minus 5 is 4. So if we have a right-left length that we want to find, like this side, we'll do right minus left. Here's the trick for this one, though. It needs to be in terms of y. So normally I'm thinking this is y equals x squared, and this is y equals 4. So my right side is that side, but I need it in terms of y. So I don't want to say x squared. I want to solve that for x so that I have something in terms of y. So what does x equal? Square root of y. So my right-hand side is the square root of y. That's my x value because I'm doing right minus left. My left-hand side is this. What's that? It's kind of weird. I don't even use the y equals 4. That's just 0. So 0 to 4 because we're doing it in y. These are still equilateral triangles, so root 3 over 4. S squared would be square root of y squared dy. I guess just for practice, I'm going to do this one by hand, because why not? Right? Because the square root of y squared is just y, and then I can take that integral and get y squared over 2. 0 to 4, so that would be 4 squared is 16, 16 over 2 is 8. That's a safe stop. My multiple choice answer is probably just 2 root 3. Again, they give you a calculator for most of these. If they don't give you a calculator, it's because it's an easy one like that you could do by hand. I suppose I could check this just to make sure. Root 3 over 4. Math 9, 0 to 4. Oh, remember you can also switch out x and y if you know what you're doing. And I want to know if that's 2 times the square root of 3. And it is. So we did it right. Those are the yucky ones, the ones that are the y ones, because you got to switch everything around. Number 6. The region enclosed by the graphs of y equals x squared and y equals 2x again, it's nice when They give you the picture, and it's nice when you're easy to figure out which one's top and which one's bottom. It's the base of a solid. For the solid, each cross section perpendicular to the y-axis. Perpendicular to the y-axis. What's that mean in terms of this problem, Ava? For perpendicular to the y-axis. And actually, that can help us narrow down our answer choices right away. Perpendicular to the y-axis. Is this going to be a dx or a dy problem? dy. Because we're going perpendicular to the y-axis. So already I can throw out C and D. That's not going to be it. A rectangle whose height is 5 times its base. So like coming up out of the page is a rectangle that's 5 times the length of the base. Which integral gives the volume of the solid? Okay, so we already said it's going to be dy. Which means everything in the problem has to be in terms of y. Alex, how about my limits? From what to what?
0 to 4.
0 to 4. Did you know that from the picture, or did you know that because my only 2 options left were 0 to 4? Both. Good answer. We're going to go from 0 to 4. Let's see, and we're doing area of a rectangle, where this side length is S. How tall is my rectangle? This side length is S. How tall is the rectangle? 5 times as tall, so 5S. 0 to 4. 5S times S. Looking at my answer choices, that explains why the 5 is out front over there on all of those. S. Taco, to get S, am I going to do right minus left or top minus bottom? To get S. Right minus left. Jace, do I need right and left? Do I need those expressions in terms of X or in terms of Y?
In terms of y.
Why do I need them in terms of Y?
It's
This is a dy problem. So I need to switch that around. I need to switch both of those around. So Avery, what's another way to say y equals x squared? If I solve this for x, what would I get? Square root of y. So those are the same equation, just sort of rearranged. Jake, what's another way to say y equals 2x?
X equals 2, or x equals y over 2.
Good, x equals y over 2. And so my side length is the right-hand side, which is the square root of y, minus the left-hand side, which is y over 2. Right minus left. So let's see, 0 to 4. I'm peeking ahead at my answer choices here. I can pull the 5 out front. What is the difference? Oh, one's minus and one's plus. S squared. S is square root of y minus y over 2 dy. So that would be answer choice A. They like to write problems like that because they can put this problem on the no calculator test. Right? The test kind of the same concept, but you don't need a calculator for it. Okay. Next notes are revolution, but we'll save our revolutions for tomorrow when we bring our pitchforks and torches and whatever else we're bringing. Don't want to get any more violent than that, especially while recording. So let's go to worksheet 2. Okay, we have a lot of time left today. I want us to maybe not finish, but hopefully get close to finishing worksheet 2. So let's see. You may use a calculator except when indicated. So the assumption is use a calculator unless it specifically says no. All right. So why don't you try 1 and 2? You don't have to show this line because you've already done that by telling me what S is and knowing that I can put that expression in for S if I like. So you don't have to show it. It might be helpful because that's what's got to go in the calculator. 0.25, math 9, 0 to 8. And then, parentheses and cube roots. And so I'm going to go x to the 1/3 minus x over 4. Square that, dx, and that should be my answer. I hope it's one of my answer choices. Thinking a while for that one, but there it is. Goodness. Yeah, I don't know what I was thinking we would do some revolutions today. That was a little much. All right, so again, try some more of that worksheet. Could argue there's only 4 more problems left. That's a little misleading because they are in parts, but 4 more problems left. And then tomorrow, bring your pitchforks and torches, and we will start some revolutions.